No existing project combines AI code generation. WTC Digital Reconstruction Landscape. A competitive analysis. No existing project combines AI code generation, self-evolving systems, and community participation for WTC reconstruction. The landscape features static 3D models, manual reconstructions, and traditional memorial experiences, creating a significant opportunity for an AI-driven, community-powered approach. Your proposed architecture of 323 AI foreman generating floor code with a self-improving head foreman represents a genuinely novel methodology not found anywhere in digital heritage preservation. Hashtag the current WTC digital reconstruction ecosystem. The market divides into 5 distinct categories: official memorial experiences, 9/11 Memorial and Museum, community 3D models, Sketchfab, TurboSquid, academic reconstructions, university/NIST, VR experiences, Targos, surviving 9/11, and web-based viewers, limited. Each has significant strengths and limitations that define the competitive opportunity. The 9/11 Memorial and Museum offers the most comprehensive official digital presence. Their platform includes 60-minute live Zoom virtual tours, an interactive timeline at timeline.911memorial.org with minute-by-minute 9/11 chronology, searchable databases of 71,000 plus artifacts, and apps featuring audio guides narrated by Robert De Niro. Critically, however, they offer no detailed 3D reconstruction of the original Twin Towers. Their focus is on the current memorial site, not the pre-9/11 buildings. SciArc's 3D Explorer provides professional-grade documentation of the memorial site through photogrammetry, but again focuses on the post-9/11 landscape rather than historical reconstruction. Google Earth offers accurate 3D views of the rebuilt WTC complex, not the original towers. Hashtag community models vary dramatically in quality and accuracy. The most technically impressive community reconstruction is Bruno Kane's Sketchfab model, built from original blueprints with 2.4 million triangles and full texturing. It offers first-person exploration mode through Sketchfab's WebGL viewer, the closest thing to a web-based WTC experience currently available. However, it's a static model without interactive features, community elements, or AI-assisted development. The Twin Towers Project, TTP3D, represents the most ambitious ongoing reconstruction effort. Using 3ds Max and Unreal Engine 5, the team is building at 1:1 scale with centimeter precision from verified pre-2001 photographs and architectural diagrams. They've completed the sphere sculpture, Tobin Plaza, and surrounding structures, with plans for an interactive walkable Unreal Engine environment. Notably, this is entirely manual modeling, no AI or procedural generation involved. Commercial options on TurboSquid include models with 1.3 million vertices, featuring interiors, WTC lobbies, windows on the World Restaurant, stairs, hallways, for $6.99 to $99 plus. These target game developers rather than memorial or educational purposes. Project Triangles/Detail Interiors Web-Viewable AI-Powered Community Features. Bruno Kane, Sketchfab, 2.4M Triangles, no yes, no TTP 3D 1:1 cm Scale Plan no, UE5. No Patreon-only TurboSquid Complex 1.3M Vertices yes, no FE Design. itch.io 1.3M Vertices yes, no, UE4. No Mini World 3D Print Optimized no. Critical gap identified. No model explicitly claims to accurately represent all 236 perimeter columns and 47 core columns per tower. While structural drawings exist, documented in Skyscraper City forums and NIST reports, no 3D project has achieved verified architectural engineering accuracy. Hashtag VR experiences offer immersion, but lack innovation. Targos, surviving 9/11. 27 Hours Under the Rubble stands as the most sophisticated VR experience. Available free on Meta Quest TV, This Emmy-nominated documentary converts 170 plus pre-2001 panoramic photos into stereoscopic 8K VR, featuring 3D reconstructions built from original WTC blueprints and scanned museum artifacts. It achieved 1.5 million views in its first 6 months. The experience walks users through WTC Plaza to the observatory deck, but it's a passive documentary, not an interactive reconstruction. Academic projects take different approaches. Purdue University created FEA, finite element analysis, simulations of aircraft impact for engineering research. The University of Alaska Fairbanks released 256 gigabytes of structural simulation data examining WTC-7 collapse mechanisms, while Cornell Medicine developed a virtual World Trade Center with 11 computer graphic scenes specifically for PTSD treatment, not historical preservation. The controversial 08:46 student project from Engman used actual WTC floor plans and survivor interviews in Unreal Engine for Oculus Rift DK2, demonstrating that game engine reconstructions are technically feasible, but noting that even accurate projects remain manual efforts. Notably absent, any VR experience on Steam VR. The only experiences are Gary's mod and teardown workshop maps, community mods rather than dedicated applications. #AI architectural reconstruction technology has significant gaps. This research reveals the most striking competitive opportunity. No AI-powered WTC reconstruction exists, and the broader category of self-improving 3D generation systems barely exists at all. Current AI architectural tools divide into 1. 2D/rendering focus, Make-T.ai, architectures. ArchiVinci generate floor plans and photorealistic renderings, not executable 3D code. 2. 3D mesh generation. OpenAI's Shapi and tools like Meshi AI produce 3D assets from text, but lack architectural precision. 3. Procedural generation. CityEngine and Houdini create role-based architecture, but require manual configuration. 4. NeRF reconstruction. Neural radiance fields reconstruct buildings from photographs, but produce visual representations, not code. Rosebud AI. lab.rosebud.ai represents the closest analog, a text-to-3.js website builder that iteratively refines WebGL code through chat. However, it's a general-purpose tool requiring human prompting for each iteration, not an autonomous system. Research on self-improving code systems exists, but remains experimental. A 2024 paper on self-programming AI, code learning agents for autonomous refactoring, describes LLM code generation with test-driven feedback loops, but ThoughtWorks' 2025 experiments concluded that AI is not ready to create and maintain a maintainable business software codebase without human oversight, generating whack-a-mole issues requiring constant human intervention. No system combining autonomous AI code generation with 3D architectural reconstruction was found. The concept of AI foreman coordinating to build and improve 3D building code appears genuinely novel. #3.js capabilities for architectural visualization. Our mature web-based 3D technology has reached production quality for architectural applications. Neatix ArchViz demonstrates state-of-the-art 3.js capabilities, including real-time day/night lighting, sun rotation controls, and post-processing effects, SSO. Archologic provides professional-grade 3D viewers with macro-to-micro navigation, select buildings, zoom to floors, walk through spaces. Procedural city generation in 3.js is well established. Little Workshop's Infinitown creates infinite-feeling cityscapes through camera wrapping. SynthCity adds audio-visual synchronization to procedural cities. CityTour offers automatic fly/drive navigation through generated cityscapes. For music synchronization, 3.js Audio Analyzer integrates with Web Audio API for real-time frequency analysis. Existing implementations use BPM detection via Web Audio Beat Detector, shader uniforms updating dynamically with audio data, volumetric light effects using GPU GEMS 3 techniques, exposure, decay, density parameters. Critical gap. No 3.js WTC reconstruction exists. No digital recreation of the tribute in light beams exists. The technology is proven. The application to WTC Memorial is completely unexplored. Hashtag community and interactive features remain primitive. Digital memorials offer basic contribution features, but nothing approaching sophisticated community participation. Platform community features. 9/11 memorial registries, oral history submission, digital guest bookkeeper memorials, QR codes, geolocation, collaborative contribution, eternal 3D customizable virtual museum. Planned multi-user interaction, 110 stories app AR. Overlays, photo sharing, interactive map. No memorial project offers community voting on 3D content quality. No project enables user participation in reconstruction decisions. No project combines community input with AI generation. The closest analog, collaborative Wikipedia editing, hasn't been applied to 3D memorial contexts. Music integration in memorials is essentially non-existent. While the 9/11 Memorial hosts live concerts and performances, no digital memorial synchronizes 3D visualization with music. Audio-reactive 3D visualizations exist as art projects, but haven't crossed into memorial applications. Hashtag comparative ratings of existing solutions, project technical accuracy, interactivity, web access, AI/automation, community memorial impact. 9/11 Memorial Museum Targo, Surviving 9/11, Bruno Kane. Sketchfab, TTP 3D. Project TurboSquid complex NIST simulations. Hashtag your project's competitive positioning based on this analysis. A project with your proposed features would occupy an entirely uncontested position. Feature exists anywhere? Competitive advantage. AI foreman generating floor code crossmark, no first-of-kind methodology, self-rewriting head foreman crossmark, no unique, self-evolving architecture, 323 specialized floor agents crossmark, no unprecedented parallelization. Community voting on quality crossmark, no novel participation model, music synced memorial concert crossmark, no unique experiential element, web-based 3. JS access partial, Sketchfab only, full browser accessibility, accurate 236 plus 47 column, specs crossmark, no verified project, engineering grade fidelity, projected comparative rating, metric your project, potential. Best current alternative, technical accuracy. If using NIST data, TTP 3D interactivity, 9/11 Memorial web accessibility, Sketchfab AI/automation. None community features, 9/11 Memorial impact. If concert executes well, Targo, hashtag gaps. Your project uniquely addresses. The competitive analysis reveals 6 major gaps that no existing solution addresses. 1. AI-generated 3D code. All current WTC models are manually created. AI generation of 3.js building code, especially coordinated through multiple agents, is unprecedented. 2. Self-improving codebase. No production system autonomously improves its own 3D generation capabilities. The head foreman rewriting its own HTML/JS daily represents novel architecture. 3. Community participation in 3D quality. Existing memorials accept photos and stories. None enables voting on 3D reconstruction quality or community input into generation parameters. 4. Music synchronization. Despite proven technology, audio API, frequency analysis, no memorial combines 3D visualization with synchronized concert experiences. 5. Tribute in light digital recreation. The iconic 88 Searchlight installation has never been recreated in WebGL/3.js. Volumetric light techniques exist, but remain unapplied. 6. Architectural engineering accuracy. While TTP 3D claims precision, no project verifiably implements the documented 236 perimeter/47 core column structure from NIST engineering reports. Hashtag conclusion. The WTC digital reconstruction landscape is characterized by high quality but static manual models, emotionally powerful but passive VR experiences, and comprehensive but non-interactive official memorial offerings. AI-powered generation, self-evolving systems, and community participation in 3D construction represent entirely unexplored territory. Your proposed architecture. 323 AI foreman generating 3.js floor code, coordinated by a self-improving head foreman, synchronized with memorial concerts and community voting, has no direct competitor. The closest analogs, TTP-3D for accuracy, Targo for immersion, 9/11 Memorial for emotional impact, each excel in single dimensions, but none combines autonomous AI, community participation, and technical accessibility. If executed well with verified architectural specifications from NIST documentation, Angster reports contain detailed structural data including all column schedules. The project would represent both the most technically advanced and most participatory WTC memorial experience available, and the first application of autonomous AI code generation to digital heritage preservation. Analysis generated December 10, 2025, 8 days a week memorial project.